Alright, time for another DraftPhysics.com, DebatePhysics.com, also video presentation. Alright, this is a response video to an Action Lab video on the Poisson spot. It's also called something like the Argo, something like that spot. Anyway, the idea, I guess I will draw it first and then we'll play the video. So I didn't watch the video, but it has the usual hype of writing on the video that says something kind of different than the title. But it's basically saying that this can't happen, that this shouldn't happen and all that kind of crap. Like it's really hard to explain when, frankly, I think it's really easy to explain. So the idea is that you have a surface and light. So this is another one of those surface things, and you're really just doing the single impediment. But the idea is instead of a usual impediment, you have a nice round spherical surface. And what and you're going to shine light on one side, and you're going to get a little tiny spot of light. And the simple argument is that the light, going by the surface, is bent into that spot, and the trick is that it's bent to all these places, in phase and out of phase, just like the double slit experiment. My black is finally out of ink. Oh, sad, tragic truth there. Yeah, okay. All right, we'll surrender. No, that's all. I can almost get by. All right, so the idea is that it makes the ringed pattern just like any impediment would do in terms of creating fringes. And the idea is that you can't see these fringes because there isn't enough photons. It's just that simple. The outside ones cover a lot of surface, so it's the same number of photons going here and out here. In all these places, same number of photons. So obviously as the rings go further out, they get lighter and lighter and lighter. And as they go in, they get more and more secure. But it's still only in this one spot where from every angle, all the light hits one spot. Which means that if you were saying these were broken pieces of a photon, you're putting all the broken pieces in one place. And therefore able to reconstruct a photon. And you just don't have enough to see the rings. So you really are creating a ringed pattern of on, off, on, off. It really is just it's really just a slit experiment. And you're doing it in 360 degrees. So you're making a circle out of it. And that's all that really is happening. And the one you see is the one where all the photons hit one spot. Instead of hitting a whole big ring, they're all in one little tiny place. So not that hard to explain. Now the trick is there's lots of angles here that are prohibitive. So if you start making the ball bigger and bigger, the problem is that the bending of the light on the surface can't get past the surface. It's the angle's more and it crashes right into the surface of the ball. So you can't have the spot because the angle is prohibited. The angle that would create a spot is prohibited because of the size of the ball. Essentially, there's just too little, you can't get the angle. And if you use the smaller you get, then the less photons you get for fringe creation. So there's a happy medium between the right size and the possible angles and the right distance, because the distance sort of decides the angle, of course. So the closer you are, the angle is very extreme, no likelihood. Medium distance, okay. Far away distance, just down the far away one really isn't much in the way, except for atmosphere and whatever else that might dilute the light as it travels. Presumably. Yes, because it's a lower angle. The lower angles are more likely. And so it sort of proves that it can't be a wave theory, because waves would mean that all the angles are possible, and it's sort of saying that now some of these sharp angles can't happen. So it's sort of saying that the sharp angles of fringe creation doesn't happen. So when you see a pattern and it gets weaker and weaker, the weaker and weaker means something. It means that it really doesn't, no photons go this way and no photons are creating fringes that way. And so that sort of blows wave theory out of the water. All right, so we'll use that as a starting point and we'll see what he says on this subject.
Today I'm going to see if Poisson's spot still forms with the darkest ball in the world, painted with
So it doesn't matter how dark it is because this is about the photons that don't actually hit the complete surface. They're hitting the electrons on the surface. So I suppose it could matter, like dark surfaces are usually fuzzy. They have texture to them. So it's going to create a little bit, it'll probably be less effective than if it was a nice clean surface. A clean surface is probably more likely to create a good spot versus a surface that has a bunch of convolutions in it. And that's usually how you create black. Very black is usually created by creating a lot of movement on the surface. A lot of change of direction. Okay, I probably need a little more volume. At least I do. Okay, good enough, I think. Leave us continue.
Musso black. Then I'll see if we can use the properties of light to make an anti-Poisson spot called the dark Poisson spot. In my last video, I showed an interesting phenomenon.
So again, all of this just has to do with in phase, out of phase. So obviously there would be places as you move where it's going to be a spot, then no spot, then a spot, then a no spot.
That happens when you shine coherent light like a laser on a steel ball. The part of the shadow of the ball that you'd assume would be the darkest, right in the middle.
So again, your assumption is based on a kind of ignorance, right? So if you know that in principle, that's not what I turned off. I want to turn the camera off. Yeah, that's the one. Okay.
Is actually the brightest spot.
So the center has, it's a very dim spot, but yes, it's clearly a spot. There's light and there's no light further out. What the fuck is this shit? He's got a commercial already?
A lot of people misunderstood how this spot forms and assumed it happens because the ball is shiny. In fact, anytime I've shown...
So why would they assume it's because the ball is shiny? So that's... I don't think that's real. I've never even heard that before, that anybody had any physics knowledge would say that. So, too ridiculous, right? Yes.
Diffraction patterns, many people assume it's because the object is shiny, that the light's able to bend around the edges. So today I'm going to be trying it with a ball that absorbs over 99.4% of the light that hits it, to be certain that no reflections are causing the bright spot. In addition,
Alright, so it's kind of a ridiculous premise in that everybody, I think, the physicists know now, this is the same as what happens with putting a needle in front of a light, and you still get a single slit pattern because you have two surfaces. You get the two surface pattern. You get the two source pattern.
in addition to the sphere, I'm also going to be using my new Creality K2 Plus printer that I'll tell you about later in the video.
Oh, he's selling that. So, oh, it's just so bad. Ugh. This is physics. This is what the physics you want on the internet is, you know, people doing all this crap. Selling crap in their videos. I mean, shit.
To make two shapes that should show Poisson's spot as well. This is a regular disc that should make Poisson's spot just like the sphere. But this is a special spiral-shaped disc that I made. According to a research paper I read, this shape should make the light gain orbital angular momentum that will...
Oh, great. So they actually think they can give the light a spiral, you know, they can make it swirl into the spot. Ridiculous. It's just about the frequency of the light, and you're basically just taking little pieces, and you got to recreate the polarization and the phase of the light, and that's all you're doing. It's just the same. It's the same mechanism in the double slit and single slit. Same mechanism.
Will result in a dark Poisson spot in the shadow. Basically a Poisson spot with a dark hole in the middle. So this is the paint I'm using.
So that means they'll just be able to see the first ring, and the spot. And then so you have a ring, and then it's going to go dark, and then it goes light, and it goes dark, and they're just going to change what the center is by changing the distance.
It absorbs 99.4% of visible light. So it'll be shiny at first while it's drying, and then it'll reach a deep, dark black matte. Okay, here we go.
I think he could have sprayed it or something, but whatever.
Let's try it with a Musso black ball. So again, the setup is just having a laser light that gets spread out by a lens here. And then I let the light hit the ball right here and make a shadow on the back there.
So he's got it at a very high distance, so that means a small angle.
And what do we see? Right in the middle is Poisson's spot. So the spot shows up even when the ball is...
So you can sort of see that there's also fringe pattern being created by the strings holding the ball. There's fringe pattern here, so it's just doing what naturally happens is you get a fringe pattern, and it's really just being washed out by all of this extra light that he's shining by expanding the light with a lens. He has this kind of ugly, dirty pattern of light in the background, and that's basically hiding what would be even more visible fringes.
Not reflective at all. So it has nothing to do with the shininess of the ball. Now let's check if a disc works.
So obviously a disc will work. Anything will work that has edges. And it just kind of depends on how thick you make it, though. If you make it really thick and flat, then you're going to have a hard time because only one edge can make the pattern. So in a sense, you kind of want a razor blade kind of edge, some kind of, so you have one clean edge. That would be the ideal, I think. I can't say for sure, because the more surface there is, the more likely it is you're just going to bend the light into the surface.
Instead of a sphere. Wow, this actually shows up better than the sphere. The disc works really well, so you don't...
So again, it's just a slit pattern. It's just a surface pattern. And you're just saying that, look, you have a whole bunch of two-slit experiments. You're just saying, instead of doing it linearly, you're just making circular ones, and there are always two opposite sides. And the two opposite sides are sending photons to the same location. And the trick is, all the sides send it to the middle. From every single location, it goes to that middle. So all of the slit patterns have the same middle, which means all of that is going to be very bright because all of the fringe patterns, the one going this way, the one going this way, the fringe pattern going this way, the fringe pattern going this way, all of those fringe patterns have the same center.
You don't need a sphere at all. You just need a symmetrical shape like a circle. So it shows up whether or not the ball or disc is shiny or reflective. So how is this working then? Well, as Fresnel predicted, most of the time light behaves like a wave. The Huygens...
So it's obviously nonsense. This is bullshit Huygens nonsense where waves make more waves makes more waves. So again, in the double slit, this can be proven that this doesn't happen. There aren't two waves coming out of the two, one wave coming out of one slit and a wave coming out of the other slit. It's the four-source experiment. That predicts the pattern. That's the math that works. The surfaces. The surfaces are the point source. That wave center won't work. The center of a wave won't work. Fact.
The Fresnel principle tells us that these wave fronts are a sum of many spherical wavelets. You can see what I mean.
Many. An infinite number. That's really what they think. An infinite number.
If I simulate a row of point sources emitting spherical waves. These waves combine to form a wave plane front. What this means is that if you were to suddenly block this plane wave, then right at the edges you actually...
So fake, fake, phony, false, fake, fake, phony, false, fake, 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 phony, false. It don't happen. The math says right here, you take the distance between the two surfaces and essentially consider those two different sources. And that's the only way you're going to get a fringe pattern. So this is just bullshit.
have a spherical wave. And if the object is small enough, light just bends around it almost as if it's not there. But with a larger...
So again, that doesn't happen either, okay, in the sense that of course it bends around tiny things, but make the thing bigger and you'll see that, oh yeah, the light does fringes. So it creates, you can see the fringe pattern here, it's creating a fringe pattern because it's really these two sources. So this is all simulated, this is not real.
Symmetrical object, a curious effect happens. In most areas far from the edges, the waves destructively interfere, creating darkness. But at the center, the light waves constructively...
So it really doesn't create darkness, it's just that there aren't enough photons to cover all of that area. It's just not a strong enough pattern because it's a hugely wide slit.
Interfere, creating a bright spot. This demonstration was the final nail in the coffin for the corpuscle theory of light.
So this is the bullshit, okay? They didn't even think about the corpuscle. They didn't even, they didn't even pay attention to their own math as saying right to them, what does this have to do with wave centers? I don't have a wave on this surface, and I don't have a wave on this surface. So how can I use this dopey wave theory? Because it doesn't work. The surfaces don't create waves, they create diffraction. They create scatter.
And from then on, people began to think of light as waves.
People didn't think. They were told it's a wave. And they were told with all this confidence and arrogance. And they believed it for really no good reason. Nobody really showed them anything real. Water waves don't look anything like the fringe patterns created by light. They're not mathematically the same. So why this comparison? Water waves doesn't create double maximas. I mean, so the whole thing's a big fraud.
Weird enough that we can get a bright spot in the center of a shadow, but there's actually an obscure experiment I read in a research paper that talked about something called a dark Poisson spot. Dark Poisson spots result when the light hitting the backstop is spiralized, meaning it has orbital angular momentum.
So it's just an absolute nonsense concept, okay? You can't give photons, anything moving the speed of light, you can't give it two momentums. It can't go this way and that way, ever. So it's out of the realm of reasonable on its face. A photon cannot have two momentums because that means it's going to get somewhere faster than the speed of light. It's just simple geometry. The diagonal is more distance. It has to go faster than the speed of light.
Light can have spin angular momentum, or
no, it can't. Idiotic.
SAM. This means that if it hits a particle, it'll cause that particle to rotate around its own center.
So more nonsense. So they'll have no evidence of it hit a particle and spun the particle. There's no evidence of that will be demonstrated at all. Light is polarized and it does push in a direction when it hits a surface. But it's never going to push in some sort of curved direction.
But light can also have orbital angular momentum, meaning that if it hits a particle, it'll cause the particle to rotate about the light's axis. This orbital angular momentum is what's needed to make the dark Poisson spot.
No, it isn't. It's nonsense. It can't happen, doesn't happen. It's a perverse interpretation of the experimental evidence. Nonsense, garbage, rubbish. Typical exaggerated bullshit physics.
When OAM light hits a backstop, the center of the light beam will actually be dark. This is because right in the center of the spiralized wave, the electromagnetic field isn't varying.
So this is all bullshit. This drawing is all bullshit. There's none of this. They got no real evidence that light's anything like whatever the fuck this is. So just bullshit.
So that means that there's no visible light there. In order to make light that has orbital angular momentum, it's actually not very hard. And it seems too trivial that this should work, but it does.
No, it says you. So again, it's just a perverse interpretation. So again, it's just about phase, and throwing pieces from two different places and having those pieces hit and recreate a photon. And so without the two sides, what they should do is do the half circle. And then they'll see, oh, the spot is gone.
What you need is just to shine coherent light on a disk that's spiral shaped. So I 3D printed this tiny spiral shape here. And what happens is when the light hits this shape, it makes the light have a non-uniform phase distribution that.
So it's, again, yes, a non-uniform phase distribution. So that is, you have changed the places at which the two distances are the same. So from surface 1 to surface, like on a perfect sphere, it's all the same where the center is. But on this, what you would almost call a parabola, the same focuses don't exist. So the light's not going to go to the same center. So obviously it breaks the whole idea, what was created by the circular symmetry of having all of them have the same distance to the focus. There's not the same distance to the focus from each one of these surfaces.
It varies around a circle. So in essence, it spiralizes the light that hits it.
Yeah, it doesn't do any of this crap. There's no spiralizing of light. So all you're doing is seeing, see, look, you're going to see exactly what I'm claiming is the reality. Is you're going to see that there's a real fringe pattern there, and it's just that we can't see it all. So you're going to see a bright spot with the center because you've just changed where the location is of the center.
Look how cool that is. A dark spot right in the middle. Instead of a bright spot right in the middle.
So we know it's a bright spot with a hole in it. We know it's a fringe pattern.
You get a brighter spot with a dark spot right in the center. So that light hitting the center is actually spiralized light that has orbital angular momentum.
So it's actually nonsense. It doesn't have any of those things. And again, all he's done is changed what was a even distance between surfaces into very uneven. You can see this distance to the center and this distance to the center are now way off. So now you've changed the phase because you've basically changed this distance to the center, the focus. So you've just broken the focus of the lens and therefore distorted the fringe pattern. You've taken it off its center.
Researchers have actually used this light to make particles start orbiting when they shine this light on it.
Oh, bullshit. So what a pile of crap. They started making things move in a circle. Bullshit.
Now you might think that the making of Poisson's spot is limited.
Well, I mean, why would he not show that, right? If you're going to make a claim like that, I mean, it's hard enough to even move stuff with light, let alone make this claim that you're going to start swirling dust particles in the air. I mean, bullshit.
Limited to light, since light acts like a wave most of the time.
Now, it doesn't act like anything. It is something, and what it is quantized bits of energy, as Einstein sort of implied.
But if you remember your quantum mechanics, you'll know that it's not just light that acts like waves, but everything acts like waves in between.
Oh, brother. So here we're going to go to this wacky story. That the electrons are waving somewhere. So they're pretty reliable particles. They do go from one place to another pretty reliably. So all of this is just such a pile of crap.
Between measurements.
It's all rocks all the way down.
So that means that if I shot a bunch of molecules at a ball or disk, then the spot that gets hit the most would be directly behind the disk. And if you don't believe me,
So again, obviously the same center, and from every angle it's the same center.
Scientists have actually shot deuterium molecules at a disk. Deuterium is just a hydrogen molecule where each hydrogen atom has an extra neutron. These molecules actually made a Poisson spot on the backstop. So this is the...
So again, just the obvious can be stated. They're charged particles, okay, that's got 2 protons and 1 electron. Obviously, they're going to be attracted to most surfaces. Depending on how you've charged it, you can get them to go that way or you get them to go that way. So obviously, not complicated. They're really charged, okay? I mean, they have twice as many protons as they do electrons.
Actual image with the count rate of the deuterium molecules hitting the back. The center of the image has the most counts of the shadow. This blows my mind. Sometimes quantum mechanics seems fake, but then experiments like this.
Oh, see, it's just these bizarre interpretations. So because you have a bizarre interpretation and you don't think that, okay, if I actually threw, charged tennis balls by, an oppositely charged impediment, and they were, because they have a static charge, they're bent by it, I'm going to be totally surprised. No, I'm not going to be totally surprised.
Come along and show us, oh yeah, this matter and molecules that you're made of can actually act like a wave.
Oh, what a pile of crap. It's just so disgusting that they preach this shit. This absolute nonsense.
Just like light, diffracting and bending. So if you want to...
Yeah, it's not diffract. Well, diffracting is reasonable, but as long as you understand the word diffraction just means scatter is diffraction. So light gets scattered. The only time you can make a photon go in some new direction, you have to bounce it off of something real, some piece of something. It has to bounce off of it in the sense that it has to give it momentum. The momentum has a new direction, so you hit an electron that's going this way with energy going this way, and then the electron moves that way. Yeah, not a big surprise.
Try this experiment for yourself. I'll put the link to the STL file for the little disk and spiral disk that I made, so you can make Poisson spot and the dark Poisson spot.
You could cut it out of paper. I mean, that's how ridiculous this is, right? You could do this with a piece of paper, just so, it's got to be a nice razor edge you cut, but it'll work just as well as 3D printing any of this crap.
I printed these on my new Creality K2 Plus.
Okay, so enough of that. Oh, disgusting. Commercials in the middle of videos. It's disgusting. All right, so anyway, it's just the double slit, If it's just the fact that surfaces disturb photons, and it disturbs them. Either they scatter this way, the bits, or they scatter that way. And the fact is it's a 50-50 chance that the pieces will hit a surface in phase or out of phase. 50-50 chance. Alright. So, till the next time and such. So forth and whatnot. I just hate this planet. Bullshit, nonsense. Silly, unproven crap.